This video is for math teachers who include justifications in their teaching. I'm going to share two quick mathematical justifications, and then I'm going to use those as examples to talk about a quick teaching technique that can be easily added in anytime that you are having a mathematical justification in class. So let's start with the claim, any line through the center of a rectangle divides it into two congruent halves. So just to justify this, we're talking about rectangles, and specifically we're talking about the center of a rectangle. And the center is this point where the diagonals of a rectangle intersect. That's what we can call the center of a rectangle. And so what we're really talking about now is, okay, what happens when a line, any sort of line, goes through that center? Well, the claim is that actually that left half there is half of the rectangle and the right half is a congruent other half of it, that those two pieces that we've split are actually congruent to each other. So to talk through a justification of this, let's bring back a diagonal. If we have a diagonal going through the center and hitting that line in the center, we know some things about these little triangles that we've formed. For example, we know from past results that the center divides the diagonal into two equal pieces. We also see some vertical angles and some alternate interior angles. So really what we have here is two triangles that are congruent to one another by angle side angle. The same line of reasoning can be used for these green triangles with the other diagonal, but it's the same idea. The diagonal is split in half, we have some vertical angles, alternate interior angles, so we got another set of congruent triangles. And then we have these pink triangles, and those are also congruent. This one doesn't even involve our line. This is just actually from the diagonals. It forms those two congruent triangles there as well, for example, by side angle side. Now, if we take the blue and the pink and the green, and we form those all together, what we get is the half of the rectangles that we're talking about. And congruent triangles, or congruent parts being put together in the same way to make a whole, those must also be congruent. So what we really have here is that the left side is congruent to the right side. I want to quickly talk through another justification, but this time with numbers and some algebraic symbols instead of geometry, just to give us another one that we can talk about later. So let's say this claim here, any odd number can be written as the difference of perfect squares. So let's start with an odd number, and because it's odd, we know that we can actually write it as 2 times an integer plus 1. Any odd number by definition can be written that way. Now we can also add 0 on without changing anything. So by adding 0, in this case I'm actually going to add k squared and then subtract the k squared. So overall I haven't changed anything. Now let's reorder that a little bit. Let's just put the k squared first. So we have k squared plus 2k plus 1 and then minus a k squared. And now this can actually be factored, where we can have a k plus 1 that's squared. That's just rewriting the trinomial in that way, factored. And then we still have the minus k squared. But looking at this now, notice that what we actually have is something squared minus something else squared. So this is really a k plus 1 square minus a k square. So that is the difference of perfect squares. So we've taken that odd number and we've shown that we can write it as a difference of perfect squares. Now, to think about teaching, I want to bring up something that happens a lot. We know from research, for example, by Sarah Blyther Baxter, Thompson, and others, and actually this has been found in a variety of ways at different levels. When students and teachers are looking at mathematical justifications or proofs, a lot of the attention and energy we know goes on the details. We might even say that there's actually too much focus on the details. Teachers might be checking justifications and looking at all the negative signs and all of the justifications that are given for each step and how things are written. And so a lot of attention on making sure those details are correct. For students as well, a lot of the attention is on the small details and the step-by-step parts. I've even seen this live where I've been in classes where students are supposed to be working on a justification, and they are actually struggling and sitting there trying to write down step number 1 and then trying to write down justification number 1 and then trying to write down number 2 and then number 3. And they're kind of missing the bigger picture, or they're not really forming a bigger plan for their argument or working it through as an idea first. They're really trying to go right at the details, which is not a very productive way to kind of work through these sorts of claims. Another thing that we know, not just from math education, but really from economics and business and interaction research generally. There's a book that I'll mention at the end that talks about being too focused on correctness or being too focused on the good, correct ideas and not having enough space for dissenting ideas or questions or clarifications or critiques. And what the research shows is that really everybody benefits from some dissent. Everybody benefits from some critiques and from people asking seemingly annoying questions, but having to answer them and clarify actually helps the whole group. not just critiquing wrong things, but even critiquing right things helps everybody to be more clear and thoughtful in what they're doing. So here's a little teaching technique that I think can help with this. It's just the idea of outlining to promote argumentation and critique. And so let's go back to those examples, and here's what I mean by that. So if you have this justification for the rectangle claim, outlining would be to just basically take the time and also do something visual to just show the general outline, which is that this argument started by having a line through a rectangle center, and then we went through this process, but what we were really doing was we were breaking those parts into triangles, and we were breaking them into triangles that happened to be congruent. So we were breaking it up and we were showing that those were congruent triangles. And then what we did was we put it back together to see two congruent halves. So that is like the main flow of the argument, looking past each detail, but looking at what the bigger argument is doing. The start point, the end point are kind of identified, and we know like what the purpose was of all that drawing and all those hash marks and all that stuff. We now see what like the point of it was as we were going along. Looking at the second example, the idea of outlining would just be simply to take a moment and visually show and talk about what the outline was, that we started with an odd number, and then what we did was we wrote that odd number in some different ways, and we transformed the expression of the odd number, but without changing the number itself. And then we arrived at having a square minus another square. So again, we can see the start and the end of the claim. If we put this in like if-then form, we can see the if and the then. But we also see what the point was when we were doing all those algebraic manipulations. We aren't just checking, technically, are you allowed to do that? Technically, can you factor it? We're looking at the overall point, which was to rewrite it into the difference of perfect squares. So outlining, I think, has this benefits of helping the students to see the bigger picture, helping them to see what the main goal is of the argument or what the main point of the argument is. You can also see the main kind of phases of the argument. And as students do more justifications, they might actually make connections. It might be hard to make the connections if you're always focused on the details, but you might be able to make the connections across your reasoning if you look at the outlines of that reasoning. Like, for example, in geometry, there might be a lot of times where you break it down into triangles and find that those triangles are congruent. But you don't always see that in the details. You might see that in the outline. Another thing that I think outlining really helps with is it opens up specific avenues for critique or for good discussions about the argument. So for example, when you're outlining the start, you can take questions and critiques of the start. For example, in this one, students might say, well, how do we know that that one that we've drawn covers all the possible lines through the center? There could be other lines that go through the center. What if it's kind of slanted to the other way? What if it's vertical? Or what if it's horizontal? What if the line is a diagonal? Does that mess up our argument? Because it doesn't make that first triangle if it is the diagonal. So that it can kind of just focus people's attention to questions and critiques about that part of the argument. In the middle part of the outline, you could then take questions or critiques, invite those in. For example, a student might say, how did you know to draw the diagonal? Like, where did that come from? It works out nice, but how did you know to do that in the first place? And then you could talk about the center being defined by the diagonal, so that's a useful thing, or talking about, well, I want to break it up into triangles, and so diagonal is a good way to make triangles. Other students might say, is that the only way to break it up, or could I have broken it up into other triangles? And you could say, oh, yeah, we can actually break it up a different way. For example, we could drop a vertical line, or like a line that's perpendicular to the bases of the rectangle, and then that one also will break it up into triangles, and you can still prove the same thing. You also might have a student that says, I'm not really sure how the green triangles were congruent. You said it's the same line of reasoning as the blue ones, but I couldn't quite follow, and so maybe we need to clarify that and be a little bit more explicit about how the green triangles are congruent or the pink triangles are congruent. On the last part of the argument, you could invite questions or critiques, and a student might say, are you sure they're congruent halves? They look kind of different. One looks like the state of Maine, and the other one looks like a kind of clawed shoe or something. And then you could talk about rotation and how they are, still congruent if you just think of them in terms of rotation. You could have a student that might ask something like, how do you know that the congruent parts were actually put together in the same way? Because it's not like any congruent parts put together make new congruent things. You have to put the congruent parts together in the same way. And so that actually is something that might be good to clarify. Like, oh yeah, not only are the parts congruent, but they were put together in the same way with the same things matching up, and so then it does make a congruent whole. So that'd be a good thing to clarify, for example. In the number example that we had here, questions at the beginning, you could invite those based on the outline. Like, now that we've outlined it, I want some questions, I want critiques about this part. And a student might say, is this really any odd number? How do we know that it works for any odd number? They might also, over here in the middle part ask, where did this k come from? What is the k really? And help me make sure I understand what that k means, because the k came possibly out of nowhere. Also, a student might ask, how did you know to bring in k squared minus k squared, right? You could have brought in k to the fifth minus k to the fifth, or you could have brought in 3k times 7 and then minus 3k times 7, like whatever it could be, but how did you know k squared minus k squared was going to be the right thing to bring in? And that would be a chance to talk about some of the key insights about we're trying to write as perfect squares, so it's helpful to have something that's squared. Or you could share a little bit of the insight that maybe happened in the sketch work or the rough drafts before this justification. Might be the idea of the pattern of perfect squares, 1, 4, 9, 16, 25, 36, and the fact that from 1 to 4 is 3, from 4 to 9 is 5, from 9 to 16 is 7, from 16 to 25 is 9. So there's really this, actually, the odd numbers are showing up as the perfect squares are growing. And that's why we realize, oh, I kind of want to get the k squared in there, because it's really going to be k plus 1 squared minus k squared. So we knew where it was going when we put in the k squared minus the k squared. So that kind of thing is something that you could talk about or clarify by going through this outline again, and not just focusing on the details, but focusing on like the overall goal of the argument. At the end, you might invite some questions or critiques, and you might have a student that notices, wait a minute, it's not just the difference of any perfect squares, it's the difference between k plus 1 and k squared. So those are actually consecutive squares. So that's even kind of a more special sort of relationship than we thought at the beginning. So overall, this idea with outlining arguments is pretty simple. It's basically, I'm just encouraging you to take time, especially at the end of an argument or justification, but you could also do this at the beginning, but just take some time to talk about and visually lay out the overall flow and the overall components of the argument. I think this helps students see that justifications are not just the details, they're not just constructed line by line. It's not just about getting the right justification on each step of the argument. It's also about the bigger idea, the bigger goal that you're doing. I think by giving time and attention to the outline, it also balances the technical details with overall reasoning, and it can provide you with a framework for critique and discussion. Sometimes if you do a justification and just ask students for questions or critiques, they aren't sure what to say, or they might be just focused on a lot of the details. But this provides a framework for actually, no, I want some questions about how this got started. I want some questions about the middle part or the end. And it might bring those questions to the surface because they have a framework for how we're going to talk about it. And especially that gets us away from the details. The details are important, but they're not the whole thing. And I think sometimes we need to make sure to spend time and energy on the bigger picture.